Chapter 5. Minerals and Rocks. Unit 3. Landforms. This unit deals with rocks and minerals, major types of rocks and their characteristics, landforms and their evolution, geomorphic processes, weathering, mass wasting, erosion and deposition, soils formation. Chapter 5. Minerals and Rocks. The Earth is composed of various kinds of elements. These elements are in solid form in the outer layer of the Earth and in hot and molten form in the interior. About 98% of the total crust of the Earth is composed of 8 elements like oxygen, silicon, aluminium, iron, calcium, sodium, potassium and magnesium, and the rest is constituted by titanium, hydrogen, phosphorus, manganese, sulfur, carbon, nickel and other elements. The elements in the Earth's crust are rarely found exclusively but are usually combined with other elements to make various substances. These substances are recognized as minerals. Thus, a mineral is a naturally occurring organic and inorganic substance, having an orderly atomic structure and a definite chemical composition and physical properties. A mineral is composed of 2 or more elements. But, sometimes single element minerals like sulfur, copper, silver, gold, graphite etc. are found. Though the number of elements making up the lithosphere are limited, they are combined in many different ways to make up many varieties of minerals. There are at least 2,000 minerals that have been named and identified in the Earth crust. But almost all the commonly occurring ones are related to 6 major mineral groups that are known as major rock-forming minerals. The basic source of all minerals is the hot magma in the interior of the Earth. When magma cools, crystals of minerals appear and a systematic series of minerals are formed in sequence to solidify so as to form rocks. Minerals such as coal, petroleum and natural gas are organic substances found in solid, liquid and gaseous forms respectively. A brief information about some important minerals in terms of their nature and physical characteristics is given below. Physical characteristics. I. External crystal form determined by internal arrangement of the molecules, cubes, octahedrons, hexagonal prisms, etc. E. Cleavage tendency to break in given directions producing relatively plane surfaces, result of internal arrangement of the molecules, may cleave in one or more directions and at any angle to each other. E. Fracture internal molecular arrangement so complex there are no planes of molecules. The crystal will break in an irregular manner, not along planes of cleavage. F. Luster, appearance of a material without regard to color. Each mineral has a distinctive luster like metallic, silky, glossy etc. V. Color. Some minerals have characteristic color determined by their molecular structure, malachite, azurite, chalcopyrite etc. and some minerals are colored by impurities. For example, because of impurities quartz may be white, green, red, yellow etc. V. Streak. Color of the ground powder of any mineral. It may be of the same color as the mineral or may differ. Malachite is green and gives green streak, fluorite is purple or green but gives a white streak. V. Transparency. Transparent. Light rays pass through so that objects can be seen plainly. Translucent. Light rays pass through but will get diffused so that objects cannot be seen. Opaque. Light will not pass at all. V. Structure. Particular arrangement of the individual crystals. Fine, medium or coarse-grained. Fibrous, separable, divergent, radiating. X. Hardness, relative resistance being scratched. 10 minerals are selected to measure the degree of hardness from 1 to 10. They are 1. Talc, 2. Gypsum, 3. Calcite, 4. Fluorite, 5. Apatite, 6. Feldspar, 7. Quartz, 8. Topaz, 9. Corundum, 10. Diamond. Compared to this, for example, a fingernail is 2.5 and glass or knife blade is 5.5. X. Specific gravity, the ratio between the weight of a given object and the weight of an equal volume of water. Object weighed in air and then weighed in water and divide weight in air by the difference of the two weights. Metallic minerals. These minerals contain metal content and can be subdivided into 3 types. I. Precious metals, gold, silver, platinum etc. E. Ferrous metals, iron and other metals often mixed with iron to form various kinds of steel. E. Non-ferrous metals include metals like copper, lead, zinc, tin, aluminium etc. Non-metallic minerals. These minerals do not contain metal content. Sulfur, phosphates, and nitrates are examples of non-metallic minerals. Cement is a mixture of non-metallic minerals. Rocks. The Earth's crust is composed of rocks. A rock is an aggregate of one or more minerals. Rock may be hard or soft and in varied colors. For example, granite is hard, soapstone is soft. Gabbro is black and quartzite can be milky white. Rocks do not have definite composition of mineral constituents. Feldspar and quartz are the most common minerals found in rocks. Petrology is science of rocks. A petrologist studies rocks in all their aspects: with mineral composition, texture, structure, origin, occurrence, alteration, and relationship with other rocks. As there is a close relation between rocks and landforms, rocks and soils, a geographer requires basic knowledge of rocks. There are many different kinds of rocks which are grouped under three families on the basis of their mode of formation. They are I. Igneous rocks, solidified from magma and lava. E. Sedimentary rocks, the result of deposition of fragments of rocks by exogenous processes. E. Metamorphic rocks, formed out of existing rocks undergoing recrystallization. Igneous rocks. As igneous rocks form out of magma and lava from the interior of the earth, they are known as primary rocks. The igneous rocks, ignis in Latin means fire, are formed when magma cools and solidifies. You already know what magma is. When magma in its upward movement cools and turns into solid form, it is called igneous rock. The process of cooling and solidification can happen in the Earth's crust or on the surface of the Earth. Igneous rocks are classified based on texture. Texture depends upon size and arrangement of grains or other physical conditions of the materials. If molten material is cooled slowly at great depths, mineral grains may be very large. Sudden cooling, at the surface, results in small and smooth grains. Intermediate conditions of cooling would result in intermediate sizes of grains, making up igneous rocks. Granite, gabbro, pegmatite, basalt, volcanic breccia, and tuff are some of the examples of igneous rocks. Sedimentary rocks. The word sedimentary is derived from the Latin word sedimentum, which means settling. Rocks, igneous, sedimentary, and metamorphic, of the Earth's surface are exposed to denudational agents, and are broken up into various sizes of fragments. Such fragments are transported by different exogenous agencies and deposited. These deposits through compaction turn into rocks. This process is called lithification. In many sedimentary rocks, the layers of deposits retain their characteristics even after lithification. Hence, we see a number of layers of varying thickness in sedimentary rocks like sandstone, shale, etc. Depending upon the mode of formation, sedimentary rocks are classified into three major groups. I. Mechanically formed sandstone, conglomerate, limestone, shale, loess, etc. are examples. E. Organically formed geyserite, chalk, limestone, coal, etc. are some examples. E. Chemically formed chert, limestone, halite, potash, etc. are some examples. Metamorphic rocks. The word metamorphic means change of form. These rocks form under the action of pressure, volume, and temperature (PVT). Changes. Metamorphism occurs when rocks are forced down to lower levels by tectonic processes, or when molten magma rising through the crust comes in contact with the crustal rocks, or the underlying rocks are subjected to great amounts of pressure by overlying rocks. Metamorphism is a process by which already consolidated rocks undergo recrystallization and reorganization of materials within original rocks. Mechanical disruption and reorganization of the original minerals within rocks due to breaking and crushing without any appreciable chemical changes is called dynamic metamorphism. The materials of rocks chemically alter and recrystallize due to thermal metamorphism. There are two types of thermal metamorphism: contact metamorphism and regional metamorphism. In contact metamorphism, the rocks come in contact with hot intruding magma and lava, and the rock materials recrystallize under high temperatures. Quite often, new materials form out of magma or lava are added to the rocks. In regional metamorphism, rocks undergo recrystallization due to deformation caused by tectonic shearing together with high temperature or pressure, or both. In the process of metamorphism, in some rocks, grains or minerals get arranged in layers or lines. Such an arrangement of minerals or grains in metamorphic rocks is called foliation or lineation. Sometimes minerals or materials of different groups are arranged into alternating thin to thick layers appearing in light and dark shades. Such a structure in metamorphic rocks is called banding, and rocks displaying banding are called banded rocks. Types of metamorphic rocks depend upon original rocks that were subjected to metamorphism. Metamorphic rocks are classified into two major groups: foliated rocks and non-foliated rocks. Gneissoid, granite, syenite, slate, schist, marble, quartzite, etc. are some examples of metamorphic rocks. Rock cycle. Rocks do not remain in their original form for long but may undergo transformation. Rock cycle is a continuous process through which old rocks are transformed into new ones. Fig 5.1 Rock cycle. Igneous rocks are primary rocks and other rocks, sedimentary and metamorphic, form from these primary rocks. Igneous rocks can be changed into metamorphic rocks. The fragments derived out of igneous and metamorphic rocks form into sedimentary rocks. Sedimentary rocks themselves can turn into fragments, and the fragments can be a source for formation of sedimentary rocks. The crustal rocks, igneous, metamorphic and sedimentary, once formed, may be carried down into the mantle interior of the earth. Through subduction process, parts or whole of crustal plates going down under another plate in zones of plate convergence, and the same melt down due to increase in temperature in the interior and turn into molten magma, the original source for igneous rocks. Figure 5.1. Exercises. 8. Multiple choice questions. I. Which one of the following are the two main constituents of granite? A. Iron and nickel. C. Silica and aluminium. B. Iron and silver. D. Iron oxide and potassium. E. Which one of the following is the salient feature of metamorphic rocks? A. Changeable. C. Crystalline. B. Quiet. D. Foliation. E. Which one of the following is not a single element mineral? A. Gold. C. Mica. B. Silver. D. Graphite. A. Which one of the following is the hardest mineral? A. Topaz. C. Quartz. B. Diamond. D. Feldspar. V. Which one of the following is not a sedimentary rock? A. Tillite. C. Breccia. B. Borax. D. Marble. Do. Answer the following questions in about 30 words. I. What do you mean by rocks? Name the three major classes of rocks. E. What is an igneous rock? Describe the method of formation and characteristics of igneous rock. E. What is meant by sedimentary rock? Describe the mode of formation of sedimentary rock. A. What relationship explained by rock cycle between the major type of rock? 10. Answer the following questions in about 150 words. I. Define the term mineral and name the major classes of minerals with their physical characteristics. E. Describe the nature and mode of origin of the chief types of rock at the Earth's crust. How will you distinguish them? E. What are metamorphic rocks? Describe the types of metamorphic rock and how are they formed. Project work. Collect different rock samples and try to recognize them from their physical characteristics and identify their family. Table of contents. Unit 3. Landforms. Chapter 5. Minerals and rocks. Physical characteristics. Metallic minerals. Non-metallic minerals. Rocks. Igneous rocks. Sedimentary rocks. Metamorphic rocks. Rock cycle. Fig 5.1 Rock cycle. Exercises. Project work.